Solve for x. In order to solve this logarithmic equation, I'm going to use the definition of a logarithm, which basically states that I need to find the power such that when I raise it to my base, it'll give me some given quantity. So here I notice that I have the outline. I have log base 4 of x plus 3 equal to 2. So I'm going to grab my base 4, and I'm going to raise it to the second power, and that should yield the quantity x plus 3. Again, just using the definition of a logarithm. Now I can go ahead and solve this equation. So on the left hand side, 4 to the second power is 16. And then the objective is to solve for x. So I'm going to isolate x by getting rid of the positive 3 by doing the inverse operation, which is subtract 3. On the right, the 3's cancel out. I isolate x, and on the left hand side, 16 minus 3 gives me a total of 13. Now the last step that I have to do is just verify that when I put the 13 in my argument, I get something that is positive. So 13 plus 3 gives me 16, and my argument is positive, so this checks out. So my solution is x equal to 13. Let's do another problem that's similar to this one. Here I have 3 log 2 of x equal to 12, and recall that whenever the base is not specified, we're working with base 10. Now I'm going to turn to the definition of a logarithm, which tells me that I need to grab the base, raise it to some power, and that should give me some quantity m, and m is the argument. But before we do that, something that I notice is that I have a scale factor of 3. I'm going to begin this problem by dividing both sides by that scaling factor. So I'm going to divide both sides by 3. Now on the left hand side, I get log 2x. And on the right hand side, I'm going to get 12 divided by 3, which is 4. It is at this point that now I can use the power of this equation. Since I have base 10, I'm going to get 10 to the 4th equal to 2x. And then 10 to the 4th, that's just going to give me 10,000. So I have 10,000 equal to 2x. The last thing I have to do is to isolate x, and I can do that by performing the inverse operation, which would be to divide by 2. So my 2's cancel out on the right hand side, leaving me with x. And on the left hand side, half of 10,000 is going to be 5,000. So x is equal to 5,000. And since I'm going to have a positive quantity inside of my argument, since 2 times 5,000 is positive 10,000, this solution checks out. And that would solve for x.